So my main project, the kangaroo project, has already been presented twice, first by Pernilla and then by Ulrika, and it will still be presented once by Kaisa-Mari, so I'm not going to talk about that project so much, but I will say a few words more from the theoretical point of view, why we would like to include music in the lives of small children. And I will present one case of dyslexia, babies whose parents have dyslexia. So this is one case study that I'm presenting, and then a few more information about a few more ongoing studies that we have at the moment. First, I would like you to think about emerging cognition. The kind of way that we define the definition of cognition is a collection of mental actions or processes that are needed to acquire knowledge and understanding using senses, thought, and experience. And of course, this is what our whole life depends on. I mean, we are cognitive beings and we want our cognition to function as well as possible. The very first steps of this emerging cognition, of course, happen already before we are born. So it is an emerging process, ontogenetic process, and of course we can understand that it is building up gradually already during the fetal life. In the baby, we are sure to see a lot of signs of cognition already, and we can also think about the cognitive processes of adults and elderly people, and this is like a full continuum of the emergence of cognition. If we think about this from the point of view of the auditory system, so in the auditory system, of course, the key elements of cognition are language, music, and emotional sounds. I would like to ask how we can study the emergence of these. How can we study the emergence of language, music, and the perception of emotional sounds? And what would be those mental actions or processes that are related to these? What would be the important processes that we want to follow? And how is actually this process happening, unfolding? How do we start acquiring knowledge and understanding that is related to language, music, and emotions? And how exposure affects this acquisition? Well, if we start about the methods, how can we actually study this emergence? We, of course, have the brain research methods available. ERPs and MEG, they are both non-invasive methods. They are very comfortable for the babies. The babies can just sleep throughout the measurements. These measurements are completely silent, so we can play very soft, detailed sounds to the babies, and they also have a very high temporal resolution, so we can actually follow the brain's reactions to each and every sound separately. Every time after the sound is presented, we can see the response from the brain. In the MEG, we can also much better locate the sources of these activities, and as Ulrika already pointed out, we can measure from one hemisphere at a time, so from the auditory cortex on one side of the head in the babies. I want to point out also one great strength of the ERP system, because this method is completely portable. So you can take it to the kindergarten, you can take it to the school, and all the children, of course, are waving and willing to join our studies. This is the oldest brain research method, but I would say that this is also the brain research method of the future because of this property that we can actually go to the premises, we can go to the homes of the children, and we can make measurements there. And in our study in Turku, we have actually found that this is the way to reach those families with the low socioeconomic status, because they are not volunteering to come to the studies. They don't want to come to the lab. But if we call them, we tell them that we could even come to your home to make the measurements of your child, then it is much more likely that they actually do agree. One very interesting property of the MEG system is that it can even reach the fetal brain. So when the fetal brain is active, the magnetic fields from the brain of the fetus reach out from the mother's abdomen. So if we place the MEG instrument very close to the mother's abdomen, right above the fetal head, we can actually record those magnetic fields. They are very small, but we can make these recordings. In Helsinki, we have this MEG device that is presented in the 3 upper figures. So it is a flat bottom instrument that we can place against the head of the fetus. And in the US, if you really want to drive the Rolls-Royce of fetal MEG, you need to go to Little Rock in Arkansas, where they have this SARA system, which is dedicated for fetal MEG measurements, which has channels all over the mother's abdomen, so all possible signals can be recorded. And with this kind of machines, we can actually look at the baby's brain activity just like as if we were actually recording EEG, but before birth. So we know now that we have these nice methods available for studying the emergence of language, music, and emotions. And let's have a look at the mental actions or processes that we can relate to these. Breaking an expectation is a very nice cognitive process that is a lot studied in these fields of language and music. This is because the brain is actually a learning machine, and it is actually a machine that is all the time trying to predict what is going to happen next. If we were not able to predict what is probable in the near future, it would be very overwhelming for us to receive all the information all the time. This is how it feels for a person who has not learned. If you listen to a language that you don't know, this is the situation. There's just a lot of syllables coming and it's difficult to make any sense. But when you are listening to a language that you do know, you have some kind of idea what is going to happen next, and that's why it is easier to perceive it. This breaking of an expectation, this cognitive process, we study with the mismatch negativity. So you can imagine a very simple expectation, just repeating one sound over and over again. And this expectation can be then broken by presenting another kind of sound, like the red ones here. And if the expectation was formed, and if the difference between these 2 sounds was perceived, then we can measure this mismatch negativity response. Even if the baby is sleeping, even if we don't know the status of the fetus, if we can see this response, then we can know that the expectation actually has been formed. On the left, you can see the very first paper published about this topic in newborn infants by Kimmo Alho in 1990. Showing that actually newborn babies, while they are sleeping, can form this kind of expectations. And this has been replicated very many times after this, and also with MEG, as you can see on the right side. So the newborn brain is all the time forming this kind of expectations. Not only the newborn brain, but also the fetal brain. So this is the same paradigm recorded in fetuses, and the responses from the fetal brain during the last weeks of pregnancy are actually very similar compared to the newborn brain responses. So even the fetus is listening to the sounds and making expectations of them and noticing when the rules are broken, when it's not the same sound presented over and over again. And why this is important is, of course, that this is the lowest level of learning. Learning from the environment, learning to expect something. If we look at the capabilities of the newborn baby's brain, we can find out that actually this expectation forming system is quite advanced. You can make different kinds of rules to the sounds. For example, here we made a rule that always the second part of the sound is higher in pitch than the first part. So the first part of the sound can be any pitch, but always the second part is higher in pitch. And of course, obviously, the way to test if the newborn baby's brain has grasped this rule is to break it. So the way to break it is to make a sound where the first part of the sound is at any pitch, but then the second part is not higher, but it is actually lower. And again, what we can see is that even this kind of quite complex abstract rule has been grasped by the sleeping newborn's brain. This is the study that was actually mentioned already today by Christine Moon, where we made an artificial language, and we tried to see how well the newborn baby's brain can actually learn a language just based on the co-occurrences of syllables. So we made 10 pseudo-words, and they were all consisting of 3 syllables. And we just played them, the syllables, one after the other, to the baby in the recording room, in the hope that she would learn this language. So in this language, unlike in natural languages, there were no prosodic cues. There were no other cues. The only cue was the co-occurrence of the syllables. So the only way to learn this language is to appreciate the fact that always after the syllable ku, there must be syllable i, and after that there must be syllable se. But after that one, because that is the last syllable of the word, you don't know what is coming. So the next syllable is unexpected. Can you guess how long it took from the sleeping babies to learn this language? A few minutes, yes. This is the right answer. We played these syllables for the babies something like 2.5 hours because we thought that it might take some time for them to learn it, and we want to record the responses before and after learning, and we didn't know how long it takes. But we noticed that we don't have anything like before learning because they were so fast in learning this that actually all of the responses were after learning. So only a few minutes and they had learned this language. This shows the power of the statistical learning system in the newborn baby's brain. Their brains are all the time making these notes down that, okay, this sound came after that sound. So there may be something that I need to remember about these. And if it is repeated several times, it is very quickly learned. We are very interested in the brain responses in neonates because we believe that they are not only signs of learning, but they are also very relevant to understanding the individual differences between the babies. When we see these brain responses, we very often see a lot of variation in them. And this is one example. This is a brain response that can be recorded to a surprising dissonant interval that is presented amongst consonant intervals. It doesn't sound very nice. We call it an aversive sound. It's not that terrible either, but at least it's worse than the consonant sounds that we keep repeating. And when this dissonant interval is presented amongst the consonant ones, of course, again, an expectation is broken and we can see the mismatch negativity response. What is important is that the size of this response differs across the babies a lot. So some of the babies have a huge response to the dissonant sound, while others have a little bit smaller one. And what is quite important is that these responses correlate to the behavior of the infant at the age of 3 months. So the responses were recorded right after birth at the age of 1 or 2 days. But at 3 months, we made a questionnaire about the temperament to the mothers. And the mothers told us how their babies are behaving in general, and we found that there is a correlation. Those babies who show a lot of expression of negative emotions, who have a lot of cry, who have lack of self-soothing, they have also the largest responses to the dissonant sounds. They seem to be very sensitive already when they are born to this kind of aversive sound. So you could say that recording these types of brain responses could be like a first measure of the physiological part of temperament. If we think about learning prior to birth, birth itself for the auditory system, it's not any kind of a milestone. Nothing happens in the brain development that is so important at the moment when the child is born. Of course, the environment changes a lot. But the learning itself has happened already before the baby is born. And I'm showing you 2 papers that are demonstrating the learning before birth. And the first one is this one. So this one is showing prenatal learning of speech sounds. And this is a paper by Eino Partanen. And in this paper that was already mentioned here, we played to the pregnant mothers sounds which had 3-syllable pseudo-words and some variations of these pseudo-words. And they listened to these sounds every day during the late part of the pregnancy, or almost every day. And when the babies were born, we recorded their brain responses to the same pseudo-words. And what we found was that actually you can see the learning. So the brain responses to the changes in the learned stimuli were larger, clearly larger in those babies who had heard them already during the fetal period. So this is a sound that is coming from outside the mother's body. So it is not heard as well as what the mother is speaking, but even from this kind of sound, they were able to learn something, so much that it persisted even after birth. And another paper also by Eino Partanen, where we composed little melodies, and the fetuses were hearing these melodies when their mothers were listening to them during, again, the last part of the pregnancy. And after the babies were born, we recorded their brain responses to these same melodies, but now altered a little bit. So we made some slight changes to the melodies, and we were able to record brain responses from the babies who had heard these melodies during the pregnancy. And quite importantly, also in our follow-up experiment 4 months later, these brain responses were still different from the control group who had not heard these melodies before. So these are two pieces of evidence of learning during the fetal period, learning that persists after birth and even 4 months after birth, which is of course a very long time in the time perspective of the babies. Okay, so I'm going to tell you a little bit about 4 studies that we are running, which are looking at exposure effects of the sound environment. The first study I will not talk about because this has already been talked about a lot. This is a kangaroo study where we are looking at the positive effects of parents singing to their prematurely born babies. Then I have another study which is looking at the negative effects of mothers who are pregnant and who are working in very noisy environments. And then also another study about mothers who are suffering from emotional symptoms during the late part of pregnancy. And then finally, one more study about babies who are born to dyslexic parents and who are listening to singing. We know that premature birth affects the brain responses. So these exactly same brain responses that we are recording from the newborn babies actually look different if the baby was born preterm. Either recorded right after birth or then recorded at term age, they do look different. And this is something that is really well known and replicated several times. In the kangaroo study, of course, what we are doing is trying to involve the families and the newborns, the prematurely born newborns, in a sound environment that would be more beneficial to them compared to the hospital environment as such. About the mothers who are working in noisy environments, if you collect data from pregnant women working in extremely noisy environments. So this means environments that are very, very rare in Scandinavia. You don't actually find this kind of workplaces here, but you have to go to the developing countries. And what you find there is if these mothers are working full-time in the very late part of the pregnancy, you find more tinnitus and more congenital hearing impairment in the infants compared to infants of mothers who work in silent conditions. So this is of course really severe, but this is something that we don't really have so much here in the developed countries, but we do have noisy working environment. We have factories that have noise levels even above 85 decibels, and of course pregnant mothers are wearing ear protection, but this is not protecting the fetuses. Probably these noise levels are not so loud that they would cause hearing impairments, but what they could cause is the auditory system learning something that may not be so beneficial, learning co-occurrences of the noises of the machines in the factory and so on. And all of this learning is away from the learning of what the mother is speaking, which syllables come after each other in the mother speaking, which types of stress patterns are there in the mother's language, and so on. What we are doing is we are collecting data at 1 year and at 2 years from children whose mothers were working in noisy environments during the pregnancy, and a control group from quiet environments. So far, we only have the data from the 1-year-old language experiment, and here we don't have any significant differences between the groups, but we see that especially the boys whose mothers were working in noisy environments, their language results are weaker. But we are still collecting more data on this, and I believe that the results from the 2 years are more reliable compared to the 1 year. Okay, and then something about the maternal anxiety during pregnancy. This is a study called FinBrain. This is based in Turku, and it is headed by psychiatry professor Hasse Karlsson in University of Turku. And here the collection of families includes something like 5,000 families from Turku area. And here they have picked some cases where the mother has been suffering from anxiety or depression during the pregnancy. And then there is also a control group. And what we are doing after the babies are born is we are recording the brain responses of the babies to happy sounds, sad sounds, and angry sounds. The same pseudo-word paradigm as we are using in many other studies too. And what is found here is in the control group, of course you have some anxiety in the pregnant mothers, as everybody can guess. But in the cases, you see a lot more anxiety. So these are mothers who suffer from some mental problems. And in the cases, the brain responses of the babies do not correlate to the anxiety experienced by the mother during the pregnancy. But in the cases, they actually do. So the more anxiety the mothers have, the more positive are those brain response polarities when we are looking at the responses to the sad sounds. We have no idea of knowing if this is related to exposure, the mothers speaking in a different way because they suffer from depression and anxiety, maybe sleeping worse, or is it related mainly to some kind of hormonal activities that are then dictating also some of the brain development of the fetuses. This is something that we cannot conclude from these studies, but at least we can find this kind of correlation. And then finally, this study where we are looking at infants who are born to dyslexic parents and who are listening to singing. Here the idea is that dyslexia is partially inherited, and dyslexia is partially related to problems in the auditory system to structure sounds. This is a project that is headed by Professor Teija Kujala in Helsinki. And so far we have collected 270 infants, half of them born to dyslexic parents, or at least one of the parents has dyslexia and the other one has dyslexia in the family. And then half of them are completely non-dyslexic, both the parents and also their families. 50% of them in both groups are taking part in a music listening intervention. And this intervention happens when the babies are between 0 and 6 months old. They get unaccompanied singing, some very slow nursery songs, and also some faster, playful songs. And there are also some weakly accompanied singing included, but most of it is completely unaccompanied. And these singers are very professionals in producing beautiful, pure vowels. So this means that this is very far from any kind of bel canto singing. This is singing that would be produced by any one of us, just singing naturally without forming the singer's voice. This is very important, but because the vowels in the singing has to be the same ones that we are using in speaking. That is the whole idea of the intervention. We also have a full control of intervention times, which songs they are playing, what times of day, which days, and so on. So we can also correlate later those. And what we have found so far is that the brain responses recorded at birth are different in the group of babies who were born to dyslexic parents compared to the babies who were born to non-dyslexic parents. So actually, with these paradigms that we are using, we are able to show the difference at the group level in those babies in their ability to structure the auditory environment. They have weaker responses to sounds in general. They have weaker responses to many of the deviant sounds. And then again, they have stronger responses to some of the emotional sounds. What we have noticed in the intervention is that the participation rate is really, really high. So the families really enjoy this possibility to play music to their babies. And they have been instructed to choose evening songs that they like and to use the same songs. If the child wants to have the same songs, you can play the same song over and over again and every evening the same song if they want. And that seems to be indeed what they are doing. This is still an ongoing study, so we don't yet know if the brain responses will change after the intervention. Why we are using music for infants in risk for dyslexia? First of all, there are very promising results from older kids. We know that if some problems in reading and writing have already been noticed, music seems to be a very good way to alleviate these problems. Also, we know that sung vowels are more separate than spoken, so singing is actually like an easier form of speech for the auditory system in that sense. In music, we have a lot of repetition, and this increases, of course, the possibilities to learn and remember. And especially in the Finnish language, we have these short and long durations of vowels and consonants. These are very difficult for dyslexic people. And these are, of course, very easily recognized in music because it is fully woven into the rhythm of the music. So our hope is that the phoneme identities and durations would be strengthened by listening to the music. And this would then make it easier to grasp, and this would then lead to better reading abilities, but also to better vocabulary later. Okay, so this is my final kind of message. We have methods to study the emerging language, music and emotions, and of course we should do this. We should learn much more about these very interesting events that are occurring during the development. We also know several mental processes that are related to these, so these are also kind of methodological tools that we can use to understand what is happening in the brain when the brain is acquiring skills for music and language. And we are already starting to acquire this knowledge and understanding that is related to language and music and also emotions very early. This happens before birth, as has been shown today many, many times. And we must appreciate also the role of exposure in this acquisition process. So we have to think about what is the environment of the auditory system, what is around there, what kinds of sounds can be heard, so that these sounds are the best possible ones for the auditory system to actually learn to communicate via music and speech and to recognize the emotional sounds and of course also to produce them. Thank you.